this is for year-11 methods. We're going to look at question 1. Specifically, we're going to look at exponential models. So in this scenario, we've got 1,000 bacteria. It's doubling every 15 minutes. So we're trying to find a formula for it. In terms of the number of bacteria, we'll call that n, and in terms of the time t. So our model we use, the basic model we use, is n equals a b to the power t. Now we know at t equals 0, n equals a b to 0 because t equals 0. Anything to the power 0 equals 1 except 0, but that's just a special case. So we got n equals a. So at t equals 0, n equals our initial population. Now our initial population happens to be 1,000 in this case. So n equals 1,000 b to the t. Now we haven't still fully specified our model because we don't know what our b value is. But I know that it doubles every 15 minutes. So at t equals 15, our n value would equal our population will be 2,000. So I can sub this in to solve for b. And small t equals 15. I can solve this equation. I can use my CAS to help me with that. So 2,000 equals 1,000 to the power 15. When I solve that, I get I need to put an x here. When I solve this, I get b equals 1.047. 1.047. Now, once I got my b value, I can fully write down my rule. T, and I can use it to determine part B, which is asking me how long it would take for the population to reach 10,000. So we want the population to reach 10,000, but we want to know what time that occurs. So all we have to do is solve for 10,000 equals 1,000.047 t, and we're solving for t. So 10,000 equals 1,000. 1.047 to the power of, we'll call it x, but we know it's a t. So I highlight it and I solve it. Interactive, advance, solve. And I get 50.13, which round to the nearest minute is 50. So after 50 minutes, our bacteria reaches the population of 10,000. So that's how you do question number 1 of 13H. There is an alternative method you can use. It's called the regression tool. So for the regression tool, we know we have 2 data points. We know that at t equals 0, n equals 1,000, and t equals 15, n equals 2,000. So when I put this into my regression tool, I go main, spreadsheet, I enter my numbers, so we've got 0 and 1,000. Then 15, and 2000, and we'll delete the other entries. Highlight, calc, regression, AB exponential. This is very important because the AB exponential is the same model we're going to use. And I get A equals 1000, B equals 1.047, which is exactly what we found. So this might save you some time in the stack when you use it. So I still get A equals 1000 and B equals 1.047. And you do the same process, you put it back into the model and you solve for the population. So that's two methods of solving for